Right, good morning class. A very short lesson on trigonometric graphs. We still need to wrap this up. Since we have 15 minutes left, let's just 15. Is it 10? 8. Okay, no problem, whatever it is. We don't want it to go to waste. Time is of an essence. So at this point, people, we are busy with mixed examples. So you say I haven't done this yet, no? We are on page 216. Page 216. Mixed examples on page 216. Okay, so the question says solve for x. Okay, number 1. Let's pull this down here. In number 1, we are asked to solve for x for sine x minus sine x, sine squared x minus sine is equal to 0 for x is greater than or equal to negative 180 or less than or equal to 270 degrees. So looking at that there, what can we say? We're going to work out our general solution first. Okay, we're going to work out our general solution first. So how can I calculate my general solution? Can I divide by sine x here? Take sine x out, this is a common factor. We're never going to divide by sine of x because I'm going to lose a solution. Okay, never divide by x. So you take out sine x as a common factor, what am I left with? Sine x minus 1 equals 0. So now we have the product rule or the factor rule that can apply. Not so. So what do I say? Sine of x is equal to 0 or sine of x is equal to? So what did I say when it comes to 1, minus 1 and 0? Did I tell you anything about that thing? No. Okay, I'm telling you now. If you're looking at 0, 1 and minus 1, we take it to the sine graph. Okay? There's your sine graph. That is 1 and minus 1. This is 360. There's normally 180, that is 0, 90 and 270. Not so. Now, the general solution for this one here, of sine of x equal to 0. Where is sine of x equal to 0? At 0, 180, 360. Now 360 and 0 is the same. Not so. So what's my general solution for this branch? Or for this product? X is equal to 0 plus k times 360. Or x is equal to 180 plus k times 360. Do you see that, people? Is there anybody that's confused? Okay, this ties into general solution. That was done on 6.8, 9 and 10. Okay. But what we also notice, people, is that this solution, everybody looking? I know some of you are just wrapping it up now. But what you notice is that this solution happens every how many? 180 degrees. So instead of saying this, I could have written it as once x is equal to 0 plus k times 180. That there, it's equivalent to that. If you don't know that there, it's fine. Leave this out. You'll still get 2 marks doing what you did here. Okay? But you'll see me, I will always write both. Okay? Just to get you on board. Okay? On the other hand, what do we have? Sine of x is equal to 1. And for which values of x is sine x equal to 1? 90 degrees. Can you see that? So what do I say? X is equal to 90 degrees plus k times 360. Because that solution happens every 360 degrees. What must I not forget to add? K is an element of integer. But have I answered the question? Have I answered the question? No. Why? Because why? They want to solve for x in this given interval. Not so. So I say x is an element of. Let's start here. Start with k is 0. So if k is 0, what is x? 0. Is that in the interval? Yes. Let k be 1. So 0 plus 1 times 360, which is 360. That inside or outside? Outside. Not so. Now you put minus 1 in. So I get minus 360 also outside. Now let's go here. Put 0 in, I get 180, which is inside. Not so. Put 1 in by k, I get 540 outside. Put minus 1 in, I get negative 180. Inside or outside? Inside is given domain. Not so. That's equal to negative 180, as you can see here. Put minus 2 in, definitely outside. Put 0 in here, what do we get? 90. Put 1 in, outside. Not so? Put minus 1 in, I get negative 270. That's where I stop. Right, you guys got it? Okay, we'll do another one. This example on page 216, number 2. The question says, give the general solution of the equation 2 sine squared x plus 3 sine x minus 2 is equal to 0. Look, what do we see here? What do we see here? You see a trinomial maybe? Huh? So if sine was x, this would have read 2 x squared plus 3 x minus 2 is equal. Can you see the trinomial? So if we needed to factorize this, what would this give us? 2x times 2 and 1. That is plus and minus. Further on, you would have given us x is equal to half or x equal to negative. Not so. Now if you that kind of girl that can't factorize, yes, use the quadratic equations. It's our best friend, she says. Okay, use it. We always think there's something wrong with you, but it's fine. Who cares? Look, as long as you can get that sum right. Okay. So what do we say? If you have gone this route here and you replace a sine x with an x, with cos with a y, whatever. If you have gone that route, you go straight into the fact that what was x? Sine. So you say sine x is equal to half, or sine x is equal to negative. Okay. Now most of you are okay with this. So what do we say? We factorize. That simply gives us 2 sine x minus 1 and sine x plus 2. Also, and then it follows by that. Yes, Michael? Sorry? Yes, let sine equal to, she's saying, I should have written here, let sine x equal x. Okay, that's courtesy, yes, that's correct. Okay, so you're all okay with that? So what happens from here? General solution. Not so? So what do we say? My reference, x is equal to, what is arc sine of half? 30 degrees. So which question comes to mind? Which quadrant is? The sine? demonstrations to Cape Town. So sign is positive there and there, not so? So, how do we get into quadrant 1? X is equal to, this is quadrant 1. X is equal to 30 plus k times 360. Or how do we get in quadrant 2? It's 180. How do we get in quadrant 2, people? 180 minus 30 plus k times 360. Which is 150 plus k times 360. Can you see that? Well, look on this side here. What is arc sine of 2? No solution. Or arc sine of minus 2, no solution. That one doesn't work. Not so. And what must I not forget? K is an element of. Right. For homework, for the next time I see time to do this section of work, I would like you guys to do 6.11. Okay? So it could be tomorrow, it could be next week sometime. Okay? People enjoy the rest of your day. Good morning, class.